So this is a kind of a tool that may work for some of you, and it may not work for others of you. So if it doesn't work for you, then by all means just ignore it. Okay, but for a lot of you, this may be helpful. It was helpful for me. It was kind of a map, a roadmap, or a way to see where my calculations all fit in together, and to try and kind of make sense of them. Okay, so for those of you who this will work for, I am going to be adding, I'm going to start it here for Chapter 6 material, and then I'm going to be adding to it in Chapter 7 and in Chapter 8. Okay, so we'll see this again. But basically what this is I call it the mole road. The different pathways that we can take using the mole. So if we go to the start of Chapter 6, okay, at the beginning of Chapter 6, we started off basically just introducing the concept of the mole. So we'll just look at moles of A. And the first thing that we did, or that we looked at, was basically what the definition of the mole was. Okay, it was a way to group large numbers of things, and in our case, large numbers of basically molecules or atoms. Okay. So we could take moles of A, right, and we can convert that to molecules of A. And we did that conversion by using Avogadro's number. And so we had, that was 6.02 times 10 to the 23rd. Remember, that's a number that you're going to want to have memorized. Now, if A was a compound and we wanted just the number of atoms, we still use Avogadro's number, but we had to take kind of an intermediate step. Okay? So we had to go from moles of A first, okay, to the moles of our element. And then from moles of our element, we could get to atoms of the element. This first conversion to go from moles of A, moles of a compound A, to moles of our element, and that was where we used our subscripts. Alright, so the lower numbers in our formulas. Okay. I believe we used aspirin as an example there. Okay. So we went from moles of A to moles of our element by using our subscripts. And then from moles of the element, we can go to atoms of the element using Avogadro's number. So that's where we started Chapter 6 at. Okay. But we quickly saw that, we didn't, going to atoms and molecules was interesting, but it was really difficult for us to do any sort of other, reactions, because we don't want to count out 6.02 times 10 to the 23rd atoms or molecules with atomic tweezers all the time. So it wasn't a very practical calculation for us. What was much more practical for us was when we learned how to calculate from grams of a compound A to moles of A. And when we did this calculation, that was where we learned about our molar mass. And remember, we get our molar mass from the periodic table. Right? That was where we found that out. So that was the beginning of Chapter 6. Okay? And these were our basic calculations. Now, what makes this mole road super powerful? Okay, and what's very, very important for us for this mole road was because we wanted to always calculate to moles of whatever compound we're looking at, because if we can get to moles of compound A, from no matter where we started here, if we can get to moles of A, we can then convert to moles of compound B. Okay, this is the only way to be able to convert from one chemical to another. And that is a very, very powerful thing for us. Okay. And that's where our limiting reactant and theoretical yield, that all comes into play. Okay, but we couldn't do those things if we didn't have this conversion. Okay, if we weren't able to convert from one compound to another. The only way to do that is from moles to moles. Okay, we can only compare moles to moles. So this concept here, this conversion, and we call stoichiometry. Or your book calls it, so AKA, also known as, your mole-to-mole factors. And we get this conversion, this ratio, from the coefficients, right, of our balanced chemical equation. Now, what makes this mole road so cool is that once we get to moles of A, from wherever we start over here, once we get to moles of A, we can convert to moles of B, and then we can get to wherever else we want. Okay, so we have the same calculations for moles of B as we did over here. Okay, so if we get to moles of B here, we can get to molecules of B, and that's using, again, Avogadro's number. If we wanted to get to certain element here, figure out how many atoms of an element, okay, again, same pathway as we did here. We'd have to get to moles of our element using our subscripts, and then we could get to atoms of the element using Avogadro's number. But it was much more helpful for us to get from moles of B to grams of B. Okay, and that was our molar mass that we get from the periodic table. Oops. So like I said, we're going to kind of build on this. I'm going to add to it in Chapter 7, and I'm going to add to it in Chapter 8. Okay, so basically all the things in blue, all of basically anything on this page, because we haven't covered Chapter 7 or 8 yet, these are all coming from Chapter 6. Okay, so we'll add more things to it on Chapter 7 and on Chapter 8. But for now, kind of our main focus, our important pathway that's going to be the most worn out pathway that we're taking, okay, is that grams of A to moles of A to grams of B, or to moles of B to grams of B. Okay, this is by far the most used pathway, so the most calculations that you're going to do are always going to do this, grams of A to moles of A to moles of B to grams of B. Okay, so definitely want to put a lot of practice into these calculations. Chapter 6 is probably going to take the most time out of any chapter, okay, so even more than Chapter 1. This is definitely where we start getting into the the application of the math and the chemistry that we've been discussing so far. Okay, so Chapter 6 takes a lot of time, and Chapter 8 will as well, but we'll get to that once we tackle Chapter 8. Okay, definitely want to get Chapter 6 under your belt, and that's going to involve working lots of problems. Or for some of you, if working a volume of problems is not helping, perhaps working the same problems over and over will be more helpful for you. Okay, and again, everyone learns different. I don't know what's going to work for you. You're going to have to assess that for yourself. Okay, so lots of problems, or at least work through the same problems over and over. Okay, I especially recommend that with problems that you have solutions to. So maybe work through the questions that we did in our notes, work through those multiple times.